Welcome to BobMath. In this video, we have a new exercise for algebra. Well, our exercise is as follow. We have x, y, and z as real number, and x greater 1, y greater 1, and z greater 1. Show that x y plus x z plus y z divided by 2 greater than or equal square root of x square minus 1 plus square root of y square minus 1 plus square root of z square minus 1. Always before discussing the solution, try to complete the exercise to increase your skill in mathematics, then complete the video. We know that square root of x square minus 1 times y square minus 1 minus 1 all square greater than or equal 0. So square root of x square minus 1 times y square minus 1 all square plus 1 square minus 2 square root of x square minus 1 times y square minus 1 greater than or equal 0. Therefore, x square minus 1 times y square minus 1 plus 1 greater than or equal to square root of x square minus 1 times y square minus 1, and therefore xy all square minus x square minus y square plus 1 greater than or equal to square root of x square minus 1 times y square minus 1. Then xy all square minus x square minus y square plus 1 plus 1. Now we add the number x square minus 1 plus y square minus 1 to the both side of the inequality. So plus x square plus y square minus 1 greater than or equal x square minus 1 plus y square minus 1 plus 2 times square root of x square minus 1 times y square minus 1. Therefore, xy all square greater than or equal square root of x square minus 1 all square plus square root of y square minus 1 all square plus 2 times square root of x square minus 1 times square root of y square minus 1. And we know that a plus b all square equals e square plus b square plus 2ab. Now we play this property in this example. So x y all square greater than or equal square root of x square minus 1 plus square root of y square minus 1 all square. And we add the square root to the both side of the inequality. So we got square root of x square all square greater than or equal square root of x square minus 1 plus square root of y square minus 1 all square. And therefore xy greater than or equal square root of x square minus 1 plus square root of y square minus 1. We call this inequality 1. In the same way, we show that xz greater than or equal square root of x square minus 1 plus square root of z square minus 1, and yz greater than or equal square root of y square minus 1 plus square root of z square minus 1. We call this inequality 2 and this inequality 3. Now we add these inequalities 1, 2, and 3 side by side. So we got xy plus xz plus yz greater than or equal square root of x square minus 1 plus square root of y square minus 1 plus square root of x square minus 1 plus square root of z square minus 1 plus square root of y square minus 1 and plus square root of z square minus 1. Therefore, xy plus xz plus yz greater than or equal to square root of x square minus 1 plus 2 square root of y square minus 1 plus 2 square root of z square minus 1. So xy plus xz plus yz greater than or equal 2 times square root of x square minus 1 plus square root of y square minus 1 plus square root of z square minus 1. Now we multiply this inequality by the number 1 divided by 2. So we got 1 divided by 2 times xy plus xz plus yz greater than or equal 1 divided by 2 times 2 times square root of x square minus 1 plus square root of y square minus 1 plus square root of z square minus 1, and therefore xy plus xz plus yz divided by 2 greater than or equal. Now we simplify the number 2, so we got square root of x square minus 1 plus square root of y square minus 1 plus square root of z square minus 1. Therefore, this is the relationship required in this exercise. Thank you for watching, and please don't forget to subscribe to my channel for more exciting videos.